Okay guys, today we're going to talk about what happens at a subduction zone, or what happens when two plates are converging. So the most famous example, the one that you guys are sick to death of hearing about, is what's happening at the Peru-Chile Trench. And I took the clip here from your reference table. So this is what's happening. We have the Oceanic Nazca plate, and it's smacking into the South American plate. Now, if you notice here, the oceanic crust is super, super thin and skinny, and the continental crust is big and fat. And the reason that has to do with is, I like to think of it this way. Think about the ocean like a swimmer. A swimmer is swimming all day. So of course the swimmer is going to be very thin, but it's also going to be very muscular. There's not going to be a lot of fat on the swimmer, right? So its density is actually going to be more. Okay. Now think about land. The continental crust is just laying there all day. It's not doing any exercise at all, kind of like Miss Sutton in quarantine. So it's going to get a lot thicker, but it's going to be less dense. There's not going to be a lot of muscle on it. So when these two plates come together, the oceanic crust is going to subduct, and it subducts because it's more dense. And that creates two things. Where my fingertip is here, it's going to create a trench, and here's our trench right here. Let me just show you. So here's our trench, which is our deep kind of pit in the ocean. There's our trench. And the other thing it's going to create on the opposite side, a little bit off the coast, is a row of volcanic mountains. In this example, these are the Andes Mountains here. Okay? Now, when they're evenly matched, when we have land hitting land, they still call it a subduction zone. See how they're still using the boxes? Because ultimately, one bit of land is going to be a little bit more dense than another bit of land. Okay, so this actually happened about 70 million years ago. India used to be its own kind of little island, and it smashed into China. And when it did that, because they're evenly matched, one doesn't really sink beneath, they kind of just both push up. And when that happens, we're going to create a row of mountains, a mountain range, and we actually created the Himalayas. Now, they're not volcanic because nothing is subducting underneath and melting. So yeah, if you look at this one here, here's the beautiful Himalayas as seen from India. Yeah, this was India. It smashed into China. On the opposite side of this mountain range is China, and this is what the Himalayas are. Tallest mountains in the world, and they're continuing to get taller because India is still continuing to smash into China. So yeah. So the main thing I want you to remember for today's lesson is that the oceanic and the continental crusts are different. And this isn't information you have to memorize. It's all right here in the reference table. I highlighted it for you from page 10. The oceanic is made of basalt. Get it? Because it's oceanic? No? Salt water? No? Okay. The density is 3.0. It's more muscular from swimming all day, and it's very, very thin. The continental crust is made of granite, and its density is 2.7, which means it's going to be less dense, so it's going to rise above when they meet at a subduction zone, and it's going to be thick, because all continents do is just pretty much lay around. All right, go to Google Classroom, check out our question for the day.